Hello all, today we are going to talk about Cloud KMS Digital Signatures. So basically we have covered symmetric encryption and asymmetric encryption in our previous videos. So this is the third part of the video. So if you don't know that Cloud KMS is used for manage and creating encryption keys in Google Cloud, and we can create encryption keys by multiple ways, like we have software keys, hardware keys. Even we can import our existing keys into Cloud KMS, or we can link our, like you have an external key management system, you can link with Google Cloud also. And we can use trust by managed encryption keys with multiple products in Google Cloud. And we can also use Cloud KMS to create and verify digital signatures or message authentication code signatures. Today in this video, we will focus on digital signatures. So there, when you create a key, there are multiple purpose. So we have already covered symmetric encryption and asymmetric encryption. Now in this video, we are going to focus on asymmetric signing, in which we will try to create digital signatures and work on it. After that, in another video, I will work on this math signing. So what is a asymmetric sign encryption? We can say digital signature. So a digital signature is like a cryptographic output which we use to verify the authenticity of the data. So it has two parts. First of all, a signing operation, and second is a verification operation. So what is in signing operation? We use a signing key to produce a signature over raw data. So that we will do the verification process in which the signature is verified by a party or someone who doesn't know the knowledge of the signing key, which we use to encrypt that our data or use to create that signing key. So in this whole process, when we use a signing key to produce a signature over our data, we use a private key, and when during the verification process, we use a public key. But in this process, we first use the private key and then use the public key. So basically, digital signature also rely on asymmetric cryptography only, which is also known as public key cryptography. So it has also have a public and private key pair. So the private key is used to create a signature, and the corresponding that public key which we have got is used to verify the signature whether it is valid or not. Someone if someone changed the data in between, you can say that someone has the data has been compromised and signature is not valid, and like that we can use that. And also, like, suppose you have a binary data that is digitally signed by a private key. You can, if you want to check the validity of this, first of all, you have to use the public key of that private key. So whenever you create a like cryptographic key, it comes in a pair, public and private pair. So if binary signature is not valid, we can say that binary data has been tampered or it has been corrupted in the process of transmitting. So here is the steps what we have to do. First of all, signer, like anyone who is signing the data, have to create a asymmetric key that support digital signing. So as I told you that asymmetric signing support by KMS. So first of all, someone has to create this asymmetric signing in Cloud KMS. I will show you how to create that. After that, the signer performs a private key operation over the data. So if you have any data and you want to create a digital signature, so you have to perform a private key operation over that data. And you will now what will happen after that, the signer will provide the data and the digital signature to the data recipient. So once that signature has been created, you will give the data which over which you have created data digital signature and the signing and both that data and the signing signature to the recipient, like to someone else, and he will use the public key to verify whether the data has been modified or not. So suppose I have a file named text.txt and I create a digital signature using private key over that data. Now I gave someone that specific file and data and that signature, and now that person will run some commands, and with the help of public key it checks whether the data has been modified or not. If the data has been modified, the verification will fail. So suppose I will open that text.file and add some more thing in that, and when I try to verify, it gave me a error that data has been like verification has been failed. I will show you. It is a very simple process in the demo. So kind of you can see, like, in this with the help of this screenshot, we can see that a sender has like some unsigned documents or unsigned data, and he use a private key to create a hash value for that data, or we can say signature. and the recipient receives the digital signed document and the data, which is this data and signed document, and he will run decrypt with the public. If that hash value or everything is same, then he get a message that verification okay. If doesn't, it will mean it is fail. We will see how to do it, and there are some resources which I have already covered in my previous videos also, like keyrings. If you before you create anything in Cloud KMS, you need a keyring. So like in your home, you have a keyring in which you have multiple keys. Same thing is here. After that, we have keys. We can create multiple keys, and each keys can have multiple versions. After that, we have to choose a type. Type can be a symmetric. Asymmetric means it is a single, both same key will be used for encryption and decryption. And asymmetric means we have a pair, public and private pair. Purpose can be multiple purpose, like we have this multiple purpose. You can see which purpose you want to use. After that, primary version, if you are using a symmetric key, then only there is a primary version. If you are asymmetric key, there is no primary version. And every time you want to encrypt or decrypt data, you have to define which version you want to use. The state can be multiple state: enable, disable, destruction, schedule for destruction, or destroy, an algorithm. Which algorithm you want to use? So there's multiple algorithm which you can use. Like if you want a strong algorithm or different algorithm, and what algorithm your organization supports, you can choose that out. So let's start our demo and see how we can use like digital signature. I am in my Google Cloud Console. You can see I have two keyrings as of now. So this is my demo keyring which we are going to work on it. So let's click on it. After that, once we inside that keyring, we will create a key. So first of all, we will click on create key, and we will provide it a name. So we can provide it a asymmetric sign, or you can give any name which suits you. After that, we have three protection levels: software, HSM, external. Software means all that operations are performed on the software level. Cryptographic, HSM means all the operations are performed on HSM, like hardware security module, basically kind of a physical machine which is resides in Google. External means you have external key manager. So software is, if you don't want to waste so much of money, use software. If there is high level of security you want, go with HSM, but remember that each version costs you about $1 to $3. External can be your, like you have a external key manager available or you're already using, so you can connect via internet or via VPC. I will go with software only. After that, there are two options: generated or imported. So the key material will be automatically generated by Google here, or you have one more option: you can import a key material. Suppose you have already have a key inside the organization and you want to use the same key, so just click on import. But I don't have. I will show you how to do that in next in come upcoming videos. But for this, let's go with the generated key. After that, purpose, which we have talked about, our algorithm. So for symmetric, we don't have any algorithm. It is a Google symmetric key only. But for another, we have multiple options. So I will click on symmetric sign. After that, you have the option which one you want to use. Like these provide so much of, you can see. So basically, it main are eclipsed and PSS padding. So if you want to use eclipsed curve, you can use this one. Or if you want to use PSS padding, you can go with this one. So let's go with this one only. After that, click on continue. Version, key rotation, that is not available in asymmetric keys. Only in symmetric there is option to rotate the key. Click on continue. And duration for scheduled instruction. So if you want to delete your key, suppose you don't want to use the key, you can type in how many days it will automatically delete it. So as of now default is 1, but I think in upcoming days, as per Google documentation, it will be 30 days if you don't give any value. So Google recommend, like, first disable your key. After that, just put your key in the destruction state. So first, if you put your key in disable state, what will happen? If something stops working, you can just re-enable it and check or decrypt all the data and decrypt in the new key. After that, again put in this state, destruction state. Maybe something is still missing, and if stop works, you can again recover the key and use to decrypt the data or encrypt with the new key. So even once that key is destroyed, nothing can be done. Google cannot regenerate the same key, and your data will be lost forever. So make sure what you are doing. And now after that, just you can add labels also. and I'm putting this default only for 1 day, and I will click on create. My asymmetric sign key has been created. So let's go inside it and see what options we have. We can see the algorithm. We can create a new version if you want to create. And after that, we have disable destroy get public key option and copy the source name. And in overview, we can see all the of all the information which is available. Permission we can check. Use tracking if you want to track. I have not enabled this, but you can enable this specific thing. So now let's do something. Let's go to our Cloud Shell. So I have a file here, test.txt. If I do cat, here's the option cat txt dot. So these are just simple. This is a demo for signing. So there are some commands which we have to use. So this is the first command for the signing. So first of all we have to sign this. So it is asking some options like which is the version we want to use. So version we can find out from here. This is the version 1. So you have to provide the version. So version is 1. After that it is asking the key name. So you have to provide the key name. Just copy it from here. Key name is this. After that it is asking what is the keyring name. Keyring name is my demo keyring. I will provide that. After that it is asking for location. So location is Asia South 1. And after that it is asking digest algorithm. So digest algorithm you can find from here. This is the algorithm we are using. So this is SHA 256. So you have to provide that. So J 256 and input file means the file which we want to use. So that is that this name cat test.txt. This is the input test.txt and signature file. So signature file you have to file a name, give a name sign.txt. Let's copy this command and we just click on paste. Let me authorize. So this command has ran. Click on if you do ls, we can see it has created a sign.txt file. If we do cat sign.txt, we can say it is giving some kind of uh, new numbers and all that. Now uh, we have to verify whether it is correct or not. For that, you can just run this command to download the public key, but or you can just directly go to here in your versions and just click here and click on the get public key. It will show the public key here. You can just copy it here or you can download it also if you want to save. It depends how you want to use, but it shows public key every time. It doesn't mean it only shows only for one time. Just go back here. I will create a new file nano pub.key and paste that. After that, if we now this is the command to verify whether our file has been good or not. So you have to provide that public key file name. So that is pub.key. We use OpenSSL. After that, signature file. Signature is sign.txt. After that, the message file, which is the input file. If you remember, this is the input file which we have used. So we are checking whether this file has been modified while or it has been someone altered this file. So we can check with this command. So let's copy this. This is a very simple example, but you can use in a different way also for signature. But I am showing this how you can do this. So let's run this command. So see, it is saying verified. Okay, that means this file is not altered. No one has touched this file, and everything is working fine. So what will happen if someone modified this file? Suppose while transmitting, or someone came later on and just change this file. So let's try to do that also. We will go nano text.txt and we will just write a compromised control X. What you think? Whether it works or not. So let's try it out. We will run that command again. Same command. We are using OpenSSL. We are using our public key. We are using signature which we have created for that specific file which is not altered before. And now we have file which is altered and we click on OK. It is saying verification failure. You came to know that the file which is originally there, it has now altered. Someone has changed that file, or it has been modified, or it has been compromised. So like this, you can do your verification. So we can see that verification is failure. Even if you want to transmit this file to someone else, you can use first asymmetric encryption. You send that file to someone, then you decrypt that file, and then you can use that file also. So there are multiple options which you can use. So even if I so suppose you want to send this file to someone, but you know that you can send a plain text file. So what you can do, you can just go back and use any of these encryptions like symmetric or asymmetric encryption, encrypt this file and share over the internet or anywhere. And once that person receives the file, first he decrypt that file, and then he will run this verification test whether this is like changed or not. Even you can encrypt the sign also, so no one can change the sign also. This is a very simple demo which you can check whether digital signatures are working fine or not. You can implement this function in your applications and in many other things also. So this is a very simple demo. Next demo I will create on like this Mac one, which is also same kind of same only. And then I will try to create on import job also. So if you have any questions or anything, you just comment it down. I will try to help you, and you can check out the document. So I have shown here for you for this Eclipse one. So when we created our file, there is an option. Let me go inside again there. So this is when we have created for eclipsed curve one, but you may have using PSS padding option if you are choosing this algorithm. So for that there are different things. So this is this one, and if you are using RSS signature, so it is different. So you can use this like encryption is same only, just changes this only. This option like RSS padding and all that verify the signature. But here we are using SSL 256. So make sure what if you are using RSS signature or ecliptic curve. According to that, you have to use that. I will put this uh, like page details URL in that description also for your help. And if you have any issue, just ping me. I will try to help you. Thank you.